In question 1749, we were asked to select a diode that could dissipate 2.8 watts and could handle a source voltage of 470 volts peak, which means that this would have to be its minimum breakdown voltage. The thing that we need to do is translate these numbers into current. When the diode is conducting, that's when it's going to dissipate power. So, since it's conducting, the voltage drop across it will be 0.7 volts. And the definition of power is that power is equal to voltage times current, which means current is simply the power divided by the voltage. That means that this diode would be, when it's dissipating 2.8 watts, have 0.7 volts dropped across it, we can assume. And it means under those circumstances it would be dissipating, or conducting rather, at least 4 amps of current. So all we have to do now is find a current that will tolerate a maximum average current of 4 amps and a reverse breakdown of 470 volts. So again, we look at our tables. And we notice that of this upper table, only this one over here, column on the right, will handle at least 4 amps. And as for handling the reverse breakdown voltage of 470 volts, we find that only this group down here can manage it. So that means that we could select only from one of these 3 diodes in this part of the table. If we look at the lower part of the table, we'll find that all of these diodes have the current capacity to handle the 4 amps. However, again, only the diodes in this region over here can handle the reverse breakdown voltage. So that means we'd be limited to this group of diodes right over here. Any one of those would work just fine.